Hi everyone, welcome back to PW English Medium channel. Friends, as you know, we have started a new series by the name UMEED NEET English series, and this is for mainly NEET students, right? What are we going to do in this series? We are going to actually complete each and every chapter in one shot videos. We are going to talk about all the theoretical concepts. We are going to talk about all the important notes plus numericals. And the best part is that this series is available on YouTube channel, that is PW English Medium channel, and it is also available on our PW app. So if you want to have notes, whatever I'm going to write down over here, whatever the important notes that I've come up with, if you want those, please log into PW app. You can get these notes from there. And another best part is that this is absolutely free. So we have completed, as you know, last week we completed mathematical tools, right? Basic mathematics and calculus. We completed vectors also in that class. In today's class we are going to talk about motion in a straight line. So without any delay, let's start today's class. First, I'm going to tell you the basic idea behind whatever we are going to do in the next few weeks, right? Basically what I'm trying to say is, next week I'm going to come up with motion in a plane, then we are going to talk about Newton's laws of motion. So let me give you a brief idea whatever we are trying to do. So basically we have started mechanics. And when I'm saying mechanics, basically we are going to talk about two things over here. One is kinematics and the another thing is dynamics. And the another arm of this branch is dynamics, right? So when we are going to talk about kinematics, we are going to basically talk about motion of a particle, motion of bodies, but we are not going to discuss how those body has got into motion, or if there is some change in motion. You know, we are going to talk about acceleration and stuff, right? But we are not going to talk about the cause of those things. We are not going to talk about which thing has caused that acceleration, which thing has caused that change in motion. We are not going to talk about all of those things. And those causes are basically force and acceleration, right? We are going to talk about force and acceleration in dynamics. So please note that under kinematics we are going to only talk about motion and its characteristics, and also in kinematics we are going to talk about one dimensional motion, also known as rectilinear motion or motion in a straight line, right? Then we are going to talk about the very next chapter is going to be two-dimensional motion or motion in a plane or projectile motion. So they have got multiple names, right? So you don't have to worry about names. One dimensional motion, rectilinear motion or motion in a straight line, two dimensional motion, motion in a plane or projectile motion, right? After that we are going to talk about dynamics. In dynamics we are going to start with Newton laws of motion, work, power, energy, and so on. So let's keep it what we are going to talk about in today's class. We are going to talk about one dimensional motion. So let's start today's class. Before discussing what do we really mean by one dimensional motion, let me briefly explain what do we really mean by motion and what do we really mean by rest. And this is the main part. Whether we are talking about one short lecture or anything, whenever you are going to learn from me, I'm going to start from the very scratch and we are going to talk about all the complex concepts also, right? So what I want is, stick with me, watch this whole video. If you have any trouble with differentiation, integration, or solving numericals from this chapter, if you have any difficulty in reading graphs, I'm going to rectify all of those things, right? The only condition is stay with me till end of this video. Now let's come back. When we are talking about motion or rest, first of all, it is very simple and basic to define what do we really mean by motion, right? So we are going to define it as, let's suppose that we have got a body which is in a space, and whenever I'm going to talk about space, mathematically I would mean that let's draw a Cartesian plane over here, something like this, right? Let's draw a Cartesian plane. And also there is a third axis, z axis, like our world. We are living in a three-dimensional world, so we have got three axes over here. And let's suppose that we have got a point somewhere over here, and let's say this is actually, when I'm saying it is a point, let's suppose this is the position of a body. right? This is position of a body. So if this is the position of a body, I am going to say that x, y and z are the coordinates of this position. Is that clear? Now, if with respect to time, if these coordinates changes, if with respect to time these coordinates changes, then we are going to say that this body is in motion. If they don't change, we are going to say the body is at rest, right? So please remember there are three coordinates. So if any one of them, changes, or if any two of them, or in any combination they changes, we are going to say that the body is in motion, else we are going to say the body is at rest. Please note that there is actually quite a significance of this point, which is known as origin, right? That's what you call it, origin. In real world, we call this thing as a reference point or a frame of reference, right? So as I told you, whether we are talking about one shot, or if you are a student of Yaqeen NEET English batch, you know me very well. Whether we are talking about one shot videos, or we are in our full-fledged live classes, we are going to talk about the basic concepts first, right? So this is actually one of the most basic concepts of mechanics, that is frame of reference, right? This is very important. Now, it is not necessary that frame of reference will always be at rest. It can be in motion. It can also actually accelerate, right? Then we are going to talk about something else like non-inertial frame. But for now, let's just say that this is a frame of reference and we have got a body. If the coordinates of the body changes, so it goes without saying that the coordinates are changing with respect to a certain frame of reference, right? So that's what I'm not saying that. So what I'm defining motion is, quickly then we're going to move on. If coordinates changes, then with respect to time, then the body will be then the body, we are going to say the body is in motion. If the coordinates does not changes, we are going to say that it is at rest. Now the important thing is that motion and rest, both of them are relative terms. Why relative terms? Because it is when we are talking about if these coordinates are changing, so it is changing with respect to this frame of reference. It is changing with respect to this origin, right? It might not change with respect to some another frame of reference, right? So in that case, we might say that okay, the body is in motion with respect to one frame of reference, and it is at rest with respect to another frame of reference. That's why we call them as relative terms. It depends on the frame of reference whether you are going to state a body is in motion or at rest. Now the next thing is, we were talking about three coordinates x, y, z. If with respect to time only one coordinate changes, then we are going to say that the body is actually performing a one-dimensional motion, right? Also, in this chapter we are going to call it as a straight line motion. Generally, we are going to say that either the body is going something like this. So if suppose this is a ground and we have got, I'm taking two examples, let's say these are the two examples. So either the body can move something like this, or body can move something like this. Generally, we are going to talk about it. So the first half of this class is going to be dedicated about this thing, when the body is moving in a straight line, something like this, and there's going to be no other there is going to be no acceleration due to gravity over here, right? Because it is moving on a flat ground. Over here, obviously, we are going to talk about motion under gravity, right? Now let's move to some another topics. Let's also talk about position vector and displacement vector, because these two concepts are very important for our understanding. Again, we are going to actually draw a similar diagram. So let's suppose we have got x-axis over here, we have got y-axis over here. Now you already know that, let's suppose that initially the body was at this point, and let me call this point as point A, right? Let me call this point as A, and the coordinates of this point is, let's suppose it is x1 comma y1 comma z1, and then let's suppose that we have got another point over here, this is point B, and it has got coordinates as x2 comma y2 comma z2. And now I am saying that the body has has undergone, the body is in motion, it has traveled from point A to point B. Let's suppose something like this, in this way. All right. So the I mean, right now I'm not talking about displacement. Right now I'm just using the word of English. I'm saying the body has displaced, the body has moved, right? So now we are going to say that initially the body had position vector something like this, and I'm going to call this position vector as, let's say I'm going to call it as RA. I'm going to call it as RA. And if you want me to write the position vector, I'm going to say that RA can be written as easy x1 I cap plus y1 j cap plus z1 k cap in the component form, isn't it? Right? In the last basic mathematics class, we did this. So we have written RA equals to x1 I cap plus y1 j cap plus z1 k cap. It's just like how you communicate your address to your to somebody, right? First you tell everything about your address. So that's what we are doing. So x1 I cap, y1 j cap, z1 k cap. That's what we have written. Another thing, for B point, the position vector is going to be called as RB, right? So again, RB will be written as x2 I cap plus y2 j cap plus z2 k cap. Is that correct? Now, when we are going to talk about a new vector, that is displacement vector, please understand what we are trying to say. If you remember from the from the vector class, we did something like this. Let's suppose that we have got a vector A, we have got another vector B, and the tail of vector B is coincided with the head of vector A, right? Do you remember what we are trying to do? We are trying to use triangle law. So in this case, the third vector is actually the resultant of, or you can say it is actually the sum of those two vectors, right? A and B. So similarly, we can do something like over here. If I'll draw a vector, let's say I'm drawing a vector something like this, from here till here. So can I call this vector as, let's say I'm calling this vector as delta R, right? So please understand, I've got vector RA, head of RA, tail of delta RA, that I'm trying to call as position vector, and the resultant is actually RB. Please understand. So I'm going to use the triangle law and I'm going to write it for you, that RA plus delta R equals to RB, which means delta R can be written as RB minus RA, or you can also call it as RBA, right? So this is what is known as position vector. So easy peasy thing. This is known as position vector, right? So if you want to know that in how we are going to write it in component form, it is quite easy. So if we want to write it, if we want to write RB minus RA, it is quite easy. We are going to write x1 minus x2, sorry, x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. That's it. This is your displacement vector, and that's how we are going to also define what displacement is, right? Now we are going to now we can also talk about distance and displacement, right? So if you are going to talk about distance, the total length of this path, please note that the length of actual path, is distance, right? The length of actual path is distance, and the length of this, the magnitude of this displacement vector, right? Obviously, this displacement vector has magnitude as well as direction. What is the magnitude? The square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. This magnitude, this length is actually the displacement, the length of the shortest path, right? So that's why we call as displacement as a vector quantity, because it has direction also. I hope everything is clear. Then after that, we usually talk about some of the more simple things like if we are talking about motion in a straight line, because that's what our topic is, right? If we are talking about motion in a straight line and direction is not going to change, then this is very important that distance is actually equals to the magnitude of displacement. We are not going to obviously talk about something like magnitude of distance. It makes no sense because distance is nothing but magnitude. Other than that, other than this case, when the body is moving in a straight line, other than this case, always distance is always going to be greater than the magnitude of the displacement, right? Hopefully everything is clear. This is all ninth class stuff. Moving on to the next thing, that is speed and velocity. And again, these are quite simple things. The trickier part the trickier part in this chapter lies in the numerical. So we are going to talk about all of those things as well. So when we are going to talk about speed, it is rate of change of distance, obviously, right? When we are going to talk about speed, we are going to talk about two types of speed, obviously. One is average speed. Average speed is nothing but total distance upon total time. Right? Or if you are going to talk about instantaneous speed, we can say limit del t tends to 0 del s by del t. So if you remember in the last class when we were talking about like differentiation, I actually explained what this limit means. So if you have any doubt, please go back to that that calculus. I think we have just uploaded that video last week. So I have explained you what does this really means, right? So have a look at that. And obviously we are not going to use this formula. Generally we are going to write it as ds by dt, right? That is, if you are going to differentiate a distance time relation, a distance time equation, you are going to get instantaneous speed. Similarly, we are going to also talk about the average velocity. So average velocity can be actually written as, again it can be written as the displacement upon time. I'm going to use another formula. If sometimes what happens, they give you equation of velocity with respect to time, right? So what you can do is you can actually write something like v dot dt divided by dt. You can write something like this also. So this is nothing but this is displacement divided by time. And if you guys have any doubt over here that what we have used in this formula, I have got one question to explain this. So we are going to talk about it. Hang on. But still, for now as well, we know that velocity is actually ds by dt, isn't it? Right? So this implies that I can write ds as integral of v dot dt. That's what I can write, isn't it? So that's what I've written. Instead of displacement, I've written v dot dt, integral of v dot dt divided by integral dt. So average velocity, that's how you're going to write it. And this is, and if we want to actually write instantaneous velocity, I can just write it as instantaneous velocity. I can use the same formulas, no big difference, right? So this is very important how we are going to use all of these things. Another thing is velocity may be positive, negative or zero. This is absolutely true, and it is absolutely true for all the vector quantities. Direction of velocity is always in the direction of change in position. This point is actually is quite useful for you, right? many a times you are going to actually use this thing. So see, direction of displacement and direction of velocity is always same. It makes sense. Velocity is rate of change in distance, in display, rate of change of displacement, right? We cannot say the same thing for acceleration and velocity, or acceleration and displacement. Acceleration is rate of change in velocity. So the direction of acceleration is along the change in velocity. Is that correct? So this is very, very important, no matter where the particle is going. Let's suppose the body is moving in this direction. Let me give you some examples over here. Let's suppose that we have got a body which is moving something like this, right? So at any point, if this is the velocity, if this is the direction of velocity, this is the direction of displacement. No doubt about it. If let's suppose a body is moving something like this, although we are not talking about motions, I mean, we are not going to talk about motions like this, but still, if you want, if let's suppose that at this point, the velocity is in this direction, then at this point, the displacement is in this direction. If at this point, the velocity is in this direction, then at this point, the direction of displacement is also same, right? Makes sense. If you're going to talk about circular motion also, in whichever direction the velocity is, let's suppose the body is moving in counterclockwise direction, in this direction this is the direction of displacement as well. Easy things, right? And speedometer, let's not talk about speedometer, you all know what speedometer is. Let's come back to acceleration. So I have already told you that acceleration is rate of change in velocity. So when you are going to talk about like average acceleration, we are going to say that this is nothing but this is final velocity minus initial velocity divided by the time taken for this change, right? So this is what average acceleration is. Sometimes they ask you to find the direction of average acceleration. It is very important, and I'll also at this place only I'll tell you what type of questions come from here. They'll say something like, they'll say that a body is moving with 3 km/h of speed towards east. This is due east, and then it changes its velocity to 4 km/h due south. Find the average acceleration, and when they find the average acceleration, they mean to say find the magnitude as well as the direction, right? So first of all, we have to do two things. We have to look at the formula. They are saying that final velocity minus initial velocity. This is the final velocity, my friends, right? This is the final velocity, 4 km/h due south. I can draw vectors anywhere I want in space as long as I have parallelly shifted the vector, right? This is v. This is final velocity vector. This is initial velocity vector, but I'm not interested in u. I'm interested in negative times of u. So what does negative times of u means? Negative times of u basically means something like this. Is that correct? So this is what minus u would mean. So minus u is actually 3 km/h due west. So the resultant of these two things is going to be something like this. And obviously I have, for my own convenience, I have taken them as triplets. So if this is 3, this is 4, right? So this is going to be 5. So 5 km/h, and by the way 5 km/h square, right? So this is what the acceleration is the magnitude of the acceleration is going to be, and this is the change in velocity, not the acceleration. This is the magnitude. This is 5. That means this is the length of this vector, then divided by the time, right? You're going to also get the time. Right now we have just found out that this magnitude of v minus u is just 5. Please note, right? Is that correct? I've used whatever you want to call it, parallelogram law, right? So this is 5, and then let's say it took this change took it took 5 seconds for this change. So 5 divided by 5 is 1 km/h square. Now the thing is, direction is actually, you can you can state what the direction is going to be. You can just call this as phi, and you can write tan phi, right? So that's how you are going to write. You are going to actually find average acceleration. Usually what we are going to use is we are going to use instantaneous acceleration, and when we say instantaneous acceleration, we are going to write it as dv by dt. And we are going to differentiate velocity with respect to time. Also, we know that velocity can be written as, so this is dv by dt. Also, velocity can be written as rate of change in displacement. So, we are going to write it as d2x by dt square. So, this is another formula that we can write. I've got another variation over here for you, but we are going to talk about it in later on when we are going to discuss the cases over here, right? So I always tell you to remember it something like this. So if you have got like xt, you have got like displacement time relation, then just differentiate it. So you are going to get velocity time, and again then differentiate it. So you are going to get acceleration time, and if you are going to integrate it, so integration basically means a of dt. That would lead to change in velocity, by the way, right? So this is actually change in velocity. And if you're going to integrate v dot dt, you're going to get displacement, right? So this is what integration means. So dx by dt, and this is dv by dt. So always remember these things. And also, if from the last class you remember, what do we really mean, what do geometrical meaning of these things is, right? So geometrically, this basically means area under AT curve gives change in velocity. Area under VT curve gives displacement. And mind you, it gives displacement, not distance, right? So don't commit mistake over there. This is what does it means? It means that slope of xt curve gives velocity, slope of vt curve gives acceleration. We are going to use it. So that's what I'm saying, that see, revising kinematics takes no time because it's all maths, right? It is mathematics. It has got to do very little with physics. Physics is just like, okay, I mean, we are not talking about how does gravity acts, or we are not talking about anything, natural phenomena. We are talking about some formulas, some mathematical formulas, right? So this is all maths. So please note that the more practice you are going to do in this chapter, more comfortable you will get, more number of questions you will come across, more number of cases you will come across, and you will be more comfortable, right? Having said that, I told you that we are going to also talk about one more case of acceleration, but we are going to look into it using an example. So let's look at into some important points. When a particle moves with non-uniform speed, now these are some of the most basic terms that you must remember. You must have also come across these terms in grade 9. So if they say that non-uniform speed, there is acceleration, right? It's pretty simple, that when we were saying that it is nothing but it is change in velocity, though velocity has got two things. Velocity has got two things, obviously. It has got magnitude and direction. So if any one of them changes or both of them changes, we are going to say that there is acceleration. No doubt about it, right? There is acceleration. If any one of them changes or both of them changes, we are going to say that there is acceleration acting on the body, right? So acceleration of the particle must be non-zero. That's what we are saying, right? Acceleration can be written as del v by del t. Acceleration which opposes the motion of the body is called as retardation. These are some pretty simple things, right? Can we start with some numericals? Because I know you have been waiting for so long. Let's start with certain numericals. This is some of the most simple cases that you're going to come across. in the case 1 they are saying that equation of velocity is given and the distance is to be find out. Now I know there are more simpler cases than this. You can also say that okay sir, but the most simple case would be that the displacement time relation is given something like 2t square plus 3t, something like this, and they are asking that find out the velocity at 5 seconds, right? Obviously you can differentiate it dx by dt and you can find out the velocity at 5 seconds, right? You can differentiate it to, you can use power rule over here. This would be 4t, this would be 3, and then we are going to plug the value of t. So nothing so special about it, but when we are going to talk about this, why I have started solving numericals with this question, the reason is that usually students commit some mistake over here. Usually students commit some silly mistakes over here. As you have already read it, equation of velocity is given and distance is to be find out. So please understand that when they are saying that equation of velocity is given, velocity is not distance upon time, right? It is actually rate at which body covers displacement. Is that correct? So basically we are talking about dx by dt or ds by dt for that matter, ds by dt. Is that correct? But they are asking about the distance. So you have to pay some attention over here. Now look at this formula. This is given as v equals to 4 plus 2t. So what I am going to do is, and they are saying that find out the distance traveled from 1 to 3 seconds. All right. So at 1 second, at t equals to 1 second, can I find out what the velocity is? Yes, I can absolutely find out. I can find out at t equals to 1 second, the velocity is actually 6 meter per second. Everything is in SI units. And at t equals to 2 second, I can find out what the velocity is. 3 second, I can find out the velocity. At 2 seconds, the velocity is it's 8 meter per second. And again, when we are going to talk about like at 3 seconds, it will increase. That's what I'm trying to say. I know that we have got to do nothing with velocity over here. They are asking about the distance, but what I really wanted you to see is that the magnitude of velocity is increasing. So it means that I can very much with confidence I can use the formula something like this. I can say that okay, velocity is actually rate, it is actually dx by dt or ds by dt, but because it is moving in a straight line, if a particle actually moves in a straight line from here till here, and how do I know that it is moving in at a straight line? Because its magnitude of velocity is increasing, right? Else what will happen? Something like this will happen. A body is moving in a straight line, yes, but it is slowing down, it stops and it comes back, right? It moves into the opposite direction. So in that case, if you are going to use the same formula over here, you will get displacement. And in that case, distance and displacement are not going to be same, because the body is actually, it is moving in a straight line, but in between moving in straight line, it actually took a turn. And when I am saying turn, it's not a turn when a car takes, or when in a real life something turns. It's a turn something like this. Are you getting it? So the thing is, we can pretty with ease we can say that okay, ds is actually going to be equals to v dot dt, and we can integrate it, from 1 to 3, and then the displacement is going to be, the integration of 4 is going to be 4t plus t square. Hopefully you can use the power rule over here, and from 1 to 3, and you can put the upper limit. So this is going to be 12, this is going to be 9, minus this is going to be 4 and minus 1, right? So this is going to be 21 minus 5, so this is going to be 16 meters is your answer. So this is your distance, this is your displacement, both of them are same, right? But what will happen if something like this comes up? Like 4 minus 2t, and if you're going to use the same formula over here, let's suppose you did use the same formula and you said that okay, let's do it like this, integration of 4 minus 2t dt, and from 1 to 3, right? So that would basically mean that we are doing the same thing. So this would be 4t minus t square, and limits are 1 to 3. So here now I'm going to write 12 minus 9 minus 4 plus 1. So actually I'm going to get 13 minus 13, and my answer is coming out to be 0 meters. So is that what you're going to say, that the body has traveled no distance, right? Is that correct? Absolutely no. The reason is that this is actually your displacement, not distance. So this is displacement and not distance. All right. So how we are going to figure it out? We are going to figure it out using a very simple thing. Please look over here. Can you please see the formula of velocity, what they have written? They have written the formula to be velocity equals to 4 minus 2t. Look into this formula and tell me, can't you figure it out that yes, there is a possibility, just because of this minus sign, there is actually not a possibility, there is a surety that at a certain time this velocity will become 0, and after that its magnitude will start increasing, right? It's, when I'm saying magnitude, what do I mean? That the numerical value will start increasing with a negative sign. So the thing is, at that particular point the body will turn around. So the first step in these types of question is, and actually in Hindi we usually call these as palti marne wale questions, and in English you can call them as turn around questions. So to solve some of these questions, the first step you need to do is, step 1, find out, step 1, find time when v is 0. This is very important, and that time is going to be, so let's just substitute v equals to 0. So 4 minus 2t equals to 0. So that time is coming out to be 2 seconds. So now let's just break the question down. So now we are going to actually write something like, we are going to write the total distance. The total distance is going to be integral of v dot dt, that means 4 minus 2t from 0 to 2 seconds plus 4 minus 2t from 2 to 3 seconds. Also one more thing, use modulus if you have to, if you are coming up with a negative sign, right? So this is what you are going to do. Please solve it. I hope you can solve it by your own. So that's how you're going to find out the distance traveled whenever some questions like this comes, right? Now let's move to some questions, and I've got a question for you. The question says, and see, I know that this is recorded, but I really want you to solve it. I'm going to solve it anyway. So what you do is, whenever I'll read a question for you, I'll step aside for a moment, pause the video, quickly solve it, then I'll come back. The question says a point moves in a straight line so that the displacement x meter time t seconds is given by x square equals to 1 plus t square. Please understand, so they are saying that this is actually something like, it is x square equals to 1 plus t square. So please note that I'm not using some very simple questions over here. Even if you are trying for NEET, and I always say that my classes are for NEET, and if you're preparing for JEE, you can make your basics strong over here. So this is a little bit different. You just have to use power rule along with the normal you have to use chain rule along with the normal power rule. So you have to find out the acceleration over here. Take your time, pause the video and let's start. Okay, hopefully you have paused it, you have tried it. Now I'm going to start. The first thing that you need to do over here is how to differentiate it. Now I want you to be very fast, but for the first time I'm going to explain it how I'm trying to solve it, right? And I'm going to explain it over here. See how I'm doing it. It is actually x times x equals to 1 plus t square, and they are talking about acceleration. I'm breaking this quotient down into small bits so that everyone can understand. Acceleration basically means dv by dt, and dv by dt basically means d2x by dt square. What do we mean by this? We mean to say that we have to differentiate displacement time relation twice, so to get acceleration. Is that correct? So for doing that, we have got, I've written instead of x square, I've written x and x. So I'm going to use I'm going to use product rule. After doing this, I'll explain to you how to do it very quickly, right? So you differentiate x dx by dt with respect to time, obviously. You keep another x as it is, then do the same thing using the power rule. You differentiate other one, right? Equals to differentiation of 1 would be 0, differentiation of t square is 2t, right? But we don't have this much amount of time, and we really don't need to actually break these things in such a way. So how we are going to do is, we are going to just see, okay, I've got this 2 over here. Just look at as a chain rule. This is outside function 2. Bring it down, right? Whatever is inside, you're going to say, sir, x is inside. Drop that power from, decrease that power by 1. So 2 minus 1 is 1. Multiplied by, go inside, differentiate the inside function, that is x dx by dt. Is that correct? If you're not getting it, pause the video, rewind it, watch it. If still you don't get it, watch my calculus class. I have explained chain rule thoroughly over there. Similarly, we are going to do the same thing on the right hand side. This is going to be 2t. I can cancel out this 2 over here. Can you please see this equation? I have written x times dx by dt. By the way, dx by dt is nothing but a velocity, equals to t. This is the thing, right? Obviously, I have to find out d2x by dt square. So see what I'm going to do. I'm going to again differentiate it this. And I'm just taking so much of time because I'm also speaking, I'm also explaining. When you're going to do it, you're quickly going to solve it. So it won't take more than 40 seconds for you. So again, let's differentiate it, use product rule over here. So first differentiate x. So it would be dx by dt. We have got one more dx by dt plus, please remember, we are using product rule, do not jump to the t side. Okay, we have differentiated x, we have written this term as it is. Now we are writing x as it is and we are differentiating the next term. So we are going to write x into d2x by dt square. Have you got it? And we have got our acceleration. I mean, at least we have got our acceleration in this equation, right? Equals to differentiation of t with respect to t will be 1. Right? Now, please try to understand over here. I have got, this is dx by dt and this is actually dx by square of dx by dt. Now, hopefully you have no trouble in distinguishing what is this and what is this. This is the double derivative of displacement time equation. This is the square of first derivative of displacement time equation, right? So, plus x d2 x by dt square equals to 1, and I have to find out what this d2x by dt square is. By the way, over here, if you're going to look, I can write dx by dt as, t divided by x. Is that correct? So this is nothing but this is t square by x square plus x times d2x by dt square equals to 1. So d2x by dt square equals to 1 minus t square by x square. Is that correct? And I've got one more x over here. right? I've got one more x over here, so I'm going to multiply it, so it will become x, and I also multiply it x, so it would become 1 upon x minus t square by x cube, 1 upon x minus t square by x cube. Hopefully you have got it, right? No more doubt. This was the first question. Now we are going to move to the next question, and again you are going to do the same thing. You are going to pause the video for a moment. I'll explain it thoroughly, and always keep a track on time. You cannot take all the time of the world and you can solve one single question. You have to be very time specific. Let's suppose that if you can easily do a problem in 40 seconds, try to do it in 30 seconds, try to do it in 20 seconds. All right, obviously the trade should not be something, the trade should not be with like time with accuracy. You have to be accurate. You can't commit silly mistakes, right? That is non-negotiable. So have a watch on time. Let's move to the next one. This is your question, and I am going to read the question, then you are going to pause it, then we are going to solve it together, right? A particle is moving along x-axis whose position is given by x equals to 4 minus 9t plus t cube by 3. Hopefully you can see that. T cube by 3. Mark the correct statement. So this is actually a multiple choice question. I mean multiple answer question. I know in NEET this is not possible. I mean, you're not going to actually select multiple choice, but what they can do is they can actually give you 4 statements, and they can then give you options, and they can say that, okay, for the first option, the first option is A and B are correct, B and C are correct. Okay, they have got this much of brain at least. So I'm talking about NTA. So now the thing is, you have to mark the correct statements for now. Pause the video, do it by yourself. All right. So hopefully you have done it. So I have got the equation as x equals to 4 minus 9t plus t cube divided by 3, right? And we have got like different things. Direction of motion is not changing. Okay, I can see over here that they are talking about something like this, that it is not changing. So this is one of the principal thing, not changing at any instant. And what is not changing? The principal thing is actually the direction is not changing, right? The direction is not changing. We are talking about this thing. Then again in the second one, they are saying that the direction of motion is changing. So first let's talk about this. Then they are talking about whether it is slowing up or speeding up. So if we are talking about direction is changing or not changing, it will depend on whether the velocity is becoming 0 at a certain point or not. So let's differentiate it. Velocity would mean dx by dt. So it would mean we can write this thing as differentiation of 4 would be 0. This would be minus 9. This would be 3t square by 3. This cancels out. Definitely there is a possibility it can be 0, na? And how you will be sure? Let's equate it to 0. So t square comes out to be 9. So t comes out to be plus minus 3. Obviously we can't take 3. So it is becoming 0 at 3 seconds. So definitely this answer is correct. Direction of motion is changing at 3 seconds. Option A is incorrect. For 0 to 3 seconds, the particle is slowing down, definitely. And then after it will speed up, because if at 3 seconds it is at rest, then after it will speed up, obviously, right? But you can also check it. And how you're going to check it? You can actually write acceleration as dv by dt. And you can differentiate it again. And you're going to actually get 2t. Is that correct? You're going to get 2t. So acceleration is always positive. It is acting, well, actually it is always increasing. Let's not say positive or negative. It is always increasing. So B, C, D are the correct answers, right? So hopefully you have got it. Now again, I'm going to give you another question, and you're going to do the same thing with me. Let's read it. You pause the video, you solve it, then we are going to discuss it. A particle moves along a straight line such that its displacement s varies with time. S equals to alpha plus beta t plus gamma t square and then you have got column 1 and column 2 with yourself, right? So quickly do it, solve by yourself, and then we are going to discuss it. So hopefully you have done it, right? So the question says a particle moves along a straight line such that its displacement s varies with time, s equals to alpha plus beta t plus gamma t square. All right, so column 1 says acceleration at 2 seconds. So let's quickly find it out. So if this is s, then velocity will be, let's differentiate it, alpha will become 0, this will become beta plus 2 times of gamma t, which means acceleration will become 2 gamma. Alright, so acceleration will become 2 gamma. I think we don't have anything to do over here, that is beta plus 5 gamma. Okay, these are nothing but these are the options, right? So for the first one it is 2 gamma, that means B option. So this will stand for B. Average velocity during third second. So that's what we were trying to do. I told you that we are going to find out how to write average velocity. So average velocity will be written as the integral of v dot dt divided by integral of dt. And when they are saying third second basically means from 2 to 3. So let's differentiate, let's integrate this equation. So obviously if you are going to integrate, you are going to land up to that. So that is alpha plus beta t plus gamma t square, and from 2 to 3 you have to integrate it, and divided by, this will obviously be 1. So that would be alpha, I'm going to solve it over here. That would be alpha plus 3 beta plus 9 gamma minus, now I'm going to put the lower limit. So I'm going to put alpha as it is, minus 2 beta and minus 4 gamma. So alpha can be cancelled out. This would mean 9 gamma minus 4 gamma would mean 5 gamma, and this is 3, this is beta. So 5 gamma minus beta. So 5 gamma minus beta. So not minus, plus beta. Plus. So 5 gamma plus beta. So this is option A. So this is for option A. Velocity at t equals to 1 second. Velocity at t equals to 1 second would mean beta plus 2 gamma. Beta plus 2 gamma is option D. And obviously this would be option now C. And you can also look at over here, initial displacement would basically means that they are talking about t equals to 0. So at t equals to 0, this would vanish, displacement would be just equals to alpha. So hopefully everything is clear till here. Now let's move to the next question. Now we have done multiple questions regarding differentiation, integration. We are going to do some more right now, so I'm not finishing up this topic. But we also have some questions regarding chasing, right? You must have seen this. This is a quite a what we can say a famous question. The question says, again you're going to solve it on your own, then we are going to discuss it. The question says a police party is chasing a dacoit in a jeep which is moving at a constant speed v. The dacoit is on a motorcycle. When he is at a distance x from the jeep, he accelerates from rest at a constant rate alpha. Which of the following relations is true if the police is able to catch the dacoit, right? So pause the video, solve it by yourself. Now I am going to start with you. So to solve this, obviously you can solve it in multiple ways, but I am going to explain the what I can say, the relative motion way, right? Relative motion method. So over here we have got, let's say we have got two things. We have got dacoit over here, and the dacoit when the dacoit sees the police jeep, which is at a distance x from it at this instance, it starts to move, and it starts to move with it starts to move from rest with an acceleration of alpha, right? And the police is moving with in a jeep with a constant velocity of v. This is the case, right? And this is the separation between them initially, that is x. This is the whole scenario. Now you have to solve it, and I'm going to explain it how you're going to do it. And I'll explain both the ways, but I'll only solve the quicker way, right? Because you have to save time. Now the thing is, the longer way is, let's suppose that the police is able to catch the dacoit after a certain point, right? So let's say that point is somewhere over here. So at this point, the distance traveled by the police would be x plus t, or let's say x plus this distance is, let's suppose it is y, x plus y, and for dacoit it would be just y. So, and the time when the police is going to catch the dacoit is going to be, let's say it is t. So it will be t for dacoit, it will be t for police. So write the second equation, equate it, you're going to find out the your answer, right? Now the thing is, instead of doing like that, let's use relative motion in one dimension, right? And when I say relative motion in one dimension, we are going to also talk about relative motion in two dimension chapter. We mean to say that let's suppose that we have got two bodies. We have got body A it is moving with VA velocity, and this body is moving with VB velocity, right? If I'll write something like this, this is B. If I'll write something like velocity of B with respect to A, what we are trying to say is, what is the velocity of B perceived by A? If you are going to ask a person at A and you are going to say that, what do you think, what is the velocity of B? So first of all, person A will say that, see, I am at rest. That's what I always say. Whenever a person is, whenever you're talking about an observer, we first thing that we do is we say that this is at rest, right? So now the thing is, to look at it in such a way, we are going to write velocity of B minus velocity of A. Mathematically, we are going to write it something like this. So if let's suppose this is moving with 30 meter per second in this direction, I'll write it over here only. If let's say this is 30 meter per second and it is 10 meter per second. So we are going to say that the velocity of B with respect to A is actually 30 meter per second I cap minus 20 meter per or 10 meter per second J cap. Sorry, I cap. And the answer is going to be 20 meter per second I cap. So with respect to A, B is moving with 20 meter per second. So after every second, the separation will increase by 20 meter between them, right? Now just change the scenario. Now the scenario is, let's suppose that it is moving with, the second case, it is moving with 20 meter per second and it is moving with 50 meter per second. Now if you are going to ask the same question, that what is velocity of B with respect to A? So again we are going to say that it is, see, it is 20 meter per second, right? Velocity of B minus 50 meter per second. That means we are going to come across minus 30 meter per second. That means after every second, the separation between them is decreasing by 30 meters. Right? Are you getting it? Now see how I explain it. How I am going to explain the similar question over here. And see, whether you are talking about velocity or you are talking about acceleration, it means the same thing. Like for example, as similarly, we are going to say It is true for all the three vector quantities. Similarly, we are going to say that acceleration of A with respect to B or B with respect to A will be written as acceleration of A minus B. This is also true, right? And I'll use an example. I'll use this question as an example. What I'm going to do is, what you want, what this question wants. This question wants police catches the dacoit. Whether it is possible or not, we have to find it out, and we have to find out the condition, right? So first of all, in our relative world, now I'm using my trick, so you will have to be a little sharp over here. First of all, if the police needs to catch the dacoit, in our relative world, let's do one thing. Let's assume the dacoit is at rest. You are going to say, sir, how you can assume it? It is not at rest. It is, initial velocity is 0, but it is moving with acceleration alpha over here. Is that correct? It is moving with an acceleration of alpha over here, right? And you're going to say, sir, actually this is part of this system. This is a system of us. Right? So please understand what I'm going to do. And this is a trick between you and me, right? Mathematically, it is absolutely correct. I'm not using any what you can say, any illicit method over here. What I'm going to do is assume the dacoit to be at complete rest. When I say complete rest, it means that it has got no acceleration, it has got no velocity, right? It is at rest. So to be at rest, obviously it has got initial velocity as 0, so I don't have any problem with that, but it has got certain acceleration. So let's do one thing. Let's apply the acceleration, the same acceleration in the backward direction. Please remember, I have told you that this is a trick for your understanding. And the same acceleration alpha over here. So what's going to happen? Now you're going to say that, okay, sir, in our relative world, I'm going to say that now this body is not, it doesn't have any acceleration, but I just can't change the acceleration of this single body. I'll have to also change the acceleration of all the body. So now this police jeep also has got an acceleration in this direction of alpha. Again, I'm saying it is nothing, whatever I have said, I've just written in the next slide. Mathematically, it is the same thing, right? So it is, we have applied the same acceleration alpha over here. Now it is at rest. This police jeep is moving with velocity v with a retardation of alpha. Now we can write the equation over here, and we are going to write it something like this. We are going to use the second equation. We are going to write displacement equals to initial velocity v, let's say it catches the dacoit at certain time t, after certain time t, minus half alpha. Why I'm writing minus, my friends? Because right now this acceleration is in this direction. I'm taking this direction as positive, the opposite direction will be negative. Minus alpha t square, and I'm going to rearrange this thing. I'm going to rewrite this thing as 2x 2vt minus alpha t square, and finally I'm going to rewrite it this thing as alpha t square minus 2vt plus 2x equals to 0. Can you please see that we have got a quadratic equation over here? We have got a quadratic equation over here, and if the police wants to catch the dacoit, it means that, let me rephrase it, if this is possible, if this question is possible that the police can actually catch the dacoit, it means that we are going to have real values of time t, right? We are going to have the real values of time t, and this is a quadratic equation, and quadratic equation has real values when the discriminant is greater than 0. I'm writing discriminant because I've already written d for the dacoit, right? I don't want any confusion. So discriminant is b square minus 4ac. Hopefully you know that. So b square basically means 2 minus 2v. So that would be 4v square minus b square minus 4a. A is alpha and c is, by the way, 2, right? So that is 2, and it should be greater than or equals to 0. So I'm going to cross alpha, so v square, and by the way, do I have also x over here? Right. So v square should be greater than 2 alpha x. This is your equation. How many steps you you needed? You just needed 2 steps, right? 1, 2, this was mere manipulation. 1, 2 and 3, boom, your answer is over here, right? So this is a very interesting thing, how to solve these things. That what if you have got questions like in what time it will catch or it will collide, right? These things are same thing. uh, Chasing, catching, colliding, all of, whenever question comes like this, please use relative motion, right? So v square must be greater than or equals to 2 alpha x. That means C option is absolutely correct. Hopefully you enjoyed it, you understood it. Moving to the next one. And now next case, actually next case, then we are going to solve some more problems, right? The next case is when velocity is given as a function of x, all right? So if velocity is given by following function v equals to x square, and again I want you to try it out, then find out the relation between x and t, all right? So now the thing is, we know that velocity can be actually written as dx by dt, and velocity is written as x square. And now after this they want us to find out the relation between x and t. So now what I'm going to do is, after this, see, this is actually very important. After this, please separate the variables with their integrating elements. This is dx, right? This says that I want to integrate it with respect to x, and I've got x square over here. So place them together. So how you are going to do it? You are going to write something like dx over x square, and you are going to write dt over here, and then integrate them. Now for initially some of you might feel that, sir, how in the world I'm going to get it, that first we'll have to do this, then we'll have to actually integrate it. Fair enough, your question is fair enough, but hear me out, hear my logic. They have given you the velocity and they are asking you about the displacement time relation. So what do you need to do? You need to integrate it, right? And if you want to integrate it, this is the thing, this is the only thing that you have to remember, that okay, I'll have to place the same variable with their integrating element, and that's how I'm going to do it. After this, obviously you can integrate it and you can write an integration constant over here, but I have got some extra information at t equals to 0. So when t was equals to 0, the body was at x equals to 1, so x was equals to 1, and when t will be some general t, then x will be some general x. This is what relation means, right? So always they are going to, they might give you some information and they will ask you a relation. So now let's solve it. So x square basically means x raised to the power minus 2. Why I'm again writing it? Because so that you can understand the power rule again, right? Dx, and again we are going to integrate it from 1 to x, equals to integration of what is with dt, there is actually 1. So integration of 1 with respect to dt from 0 to t. So this would basically mean this is nothing but this is minus 1, and we are going to write the same thing over here as well. So 1 and x equals to, this will be nothing but this will be t, so that will be t, and I'm going to substitute minus x over here, so it would be minus x, then it would be plus 1, and it would be t. Now in any way you want to write it down, right? If you have any problem, if you have done any mistake, please write down in the comment section. Hopefully I have not done it, right? Everything's clear. Case 2. Now let's move to the next question. Some more questions. Can I give you this question in homework? Let's see. For motion of an object along the x-axis, the velocity v depends on the displacement as v equals to. Okay, I can't give you this in question in homework. We'll solve it. Why? Because now here the velocity is given as a function of x, and they are talking about acceleration. If you remember, I told you that we are going to solve, if we are going to talk about a specific case of acceleration, relation between acceleration, velocity and displacement in a particular question. This is what I was talking about. So please, you try to solve it. I mean, give it a try, right? And if you are able to do it, good, else I'll solve it. So now they have given us velocity and they are asking about the acceleration. Now many of you will say that, okay sir, we know that velocity can be actually written as dx by dt and acceleration can be actually written as dv by dt. But what about this x over here? How we can actually club that? So what I'm going to do is do a little bit of, and this is actually important. So please note that you are going to actually use this thing at multiple places in this chapter. Multiply and divide dx. After that, write dv by dx together and dx by dt together. You know what dx by dt is, right? It is velocity. So from now on, you have got one more relation. Acceleration can be written as velocity times dv by dx. Important thing. Using this, we can actually solve this question. So we are going to say that we have got velocity as 3x square minus 2x and they are asking acceleration at 2 meters. So I'm going to write acceleration equals to velocity 3x square minus 2x and dv by dx. So I'm going to actually write dv by dx, and dv by dx basically means I have to differentiate it, right? So this would be 6x minus 2 and we have to find it at 2 meters. So 3 into square of 2, right? 4 minus 2 into 2, 6 into 2 minus 2. Now whatever the answer is, please try to solve it. This is going to be 12 minus 4 and this is going to be 12 minus 2. This is going to be 8 and this is going to be 8. Is that correct? Is that correct? Have we done any silly mistake? Quickly let's let's solve it. 12 minus 4 is 8 and this is actually 12, this is 4, this is 8 and this is 12 minus 2, this is 10. Do we have 80 over here? Yes, we have got 80 over here. So 80 meter per second square is the correct answer, right? If you have any doubt, please let me know in the chat box, not chat box, comment section, right? So this was another question. Now I think we can move to another topic. We have almost done every type of problem. You might come across with a new problem, but the basic concepts are going to remain same. Let's talk about motion under gravity, another part of this chapter. Now when we are going to discuss motion under gravity, let's first finish the basics. Motion under gravity will involve, let's say this is a ground, a particle can be thrown something like this with, let's say, initial velocity, right? We are going to talk about what is the maximum height attained by this particle. Whenever you are going to talk about maximum height, always remember maximum height basically means that this is the point where the final velocity becomes 0. Now I'm going to give you some points over here. You should always remember that, right? It will save a lot of time for you. And again, this is, I'm not saying that this is something exclusively taught in 11th. This is part of 9th class also. So the thing is, first of all, acceleration due to gravity is g. It always acts downwards, right? Usually if you come across a nicer question, they give you the value as 10 meter per second square. If not, take it as 9.8 meter per second square. Now the thing is, we are going to actually use the same equations of kinematics over here, right? Final velocity is 0 from point A to B, right? And let's say that this, the maximum height attained by this is actually capital H, right? So we are going to actually use the equations of final V equals to U plus A into T, right? This is, and all the other 3 equations of kinematics. By the way, we have not talked about equations of kinematics till now. Let's also talk about those equations from here. The second equation is S equals to ut plus half AT square. The reason that I have not discussed it, because I think this is quite easy. V square equals to U square plus 2AS. And also, if you want me to write this for the nth term formula, U plus A by 2 into 2n minus 1. These are some of the formulas that you must, you must be knowing it, right? Hopefully everyone knows this. Now the thing is, we are dealing with vector quantities. So what I'm going to say is, always remember that whenever we are discussing vector quantities, first define the direction. First define the sign convention. So the sign convention is something like this. Whatever the vector quantities are downward, we are going to take them as negative. And whichever vector quantities are directed upwards, we are going to take them as positive. That's it. Now, please don't ever say in 11th or 12th, or if you are a dropper student, that, oh sir, but body is moving upward or body is moving downward, so why didn't you change the sign for G? Let's not talk about all of these things, right? I don't think that that's the correct way to solve questions. Or you can solve it, your answers will be correct, but make your life simple. If anything is downward, positive, negative; if anything is upward, positive, that's it, right? It's a convention, it's not a rule. Now the thing is, when we are going to talk about these things, at any point the body will go up from A to B. So let's suppose the ascending motion is from A to B, right? And the descending motion is, you can use the same name, same points or another points, right, from B to A. Now what I am trying to say is, let's suppose at any point, let's suppose at this point, velocity was 10 meter per second. So when the body is going to come back to the same point, at this point it will also have the same velocity, 10 meter per second. Simple things. If you have any doubt, solve it by yourself. And obviously I'm not talking about air resistance over here. So air resistance is negligible. So when the particle is, if the initial velocity was u, then when the particle is going to land up, the final velocity will also be u, right? Time for ascent is always equals to time for descent when you don't have air resistance. All of these things, if you want to find out what h is, just do simple things. If you want to find out what h is, so v is 0, so use this equation to find out h, right? So v will be 0, so 0 square equals to u square plus 2, acceleration due to gravity minus g, displacement is in upward direction, so plus h, right? So h would be equals to u square by 2g. If you want to find out the time of flight, the time taken by the particle to go from A to B, use the first equation, v equals to u plus at, that's it, right? Many things you can play with these equations. Now let's come to some important points over here. I've got one important note which you can remember and you can save a lot of time. What we have got over here is, a ball is dropped from the top of a building of height h and it reaches the ground after time t. And solve it by yourself. Use the equation, solve it by yourself. So we have got a building over here. And we have dropped a body. Dropped means initial velocity is 0. And it took t1 time for this body to drop. T time for this body to come. And one similar body is being thrown, one of the body is thrown up with certain velocity. Let's say it is thrown with v velocity. Another body is thrown downward with the same velocity v. This body took t1 time, this body took t2 time to reach back. And let's say height of the tower is h. Now the thing is, the relation is actually something like this. The relation is t equals to under root of t1 minus t1 into t2. This is the relation that you need to remember. Now I'm going to explain, I'm going to write the equations for you. I'm going to write 3 equations for you, right? Hopefully this is, let's see. So if let's suppose I'm talking about this thing, let's say this is body A, body B and body C. Let me write the 3 equations. For body A, I'm going to write the equation as, I'm going to use second equation, I'm going to write minus h. Why minus h? Because displacement is in the negative direction. Initial velocity is 0, half minus g into t square. This is my first equation for body A. For body B, I am going to write minus h. Again, I am going to write minus h, and I will tell you why. See, no worries, it goes up something like this. Then it comes back, right? So the displacement is, in any way, the displacement is this, right? And it is in negative direction. So minus h equals to, yeah, but initial velocity was positive. So v into t1 minus half g into t1 square. So this is for B, which was thrown upward. Again for the third one, minus h minus v t2 minus half g t2 square. That's it. You have got 3 equations. This is your result. You need to remember the result if you want to save time in NEET exam, right? Please remember, it's all about accuracy and speed in NEET. It's not about solving things and solving complex problem. If you remember the formulas, if you remember the short tricks, you are going to save a lot of time. Moving on, if we are going to talk about air resistance, if at all we are going to talk about air resistance, what will happen? Let's see. So first of all, how does how does air resistance works? Air resistance works in such a way that if, let's suppose, if a body is moving upwards, let's suppose if a body is moving something like this, ascending motion. So for ascending motion, this is the direction of motion. I'm going to draw it something like this. This is the direction of motion. So in opposite to this, the air resistance will act. Always. And let's say the acceleration produced by this air resistance is A. Right? Also, always acceleration due to gravity will be downwards for anything on earth. So this is G, whether you're throwing something or you, and then again the point will go up, then it will come back from the same point, but I'm drawing it over here. Please note that I'm drawing it over here. Right, so if this is point A, this is point B, then this is the same point B. But now in this case, in the second case, the air resistance will act in the upward direction. Why? Because it always opposes the direction of motion. And this is the direction of motion in the second case, right? So now the initial velocity over here is going to be 0. Let's suppose the initial velocity over here is u, right? Let me write it as u dash. This is u. The final velocity over there is going to be v, and the height is actually same. So the time for ascent will be calculated as u plus, now the acceleration is a and g. So negative times of a plus g into time for ascent. So time for ascent is going to be u divided by a plus g or g plus a, whatever you want to call it. Similarly, time for descent is going to be, at this point the final velocity will be u minus u, right? Is that correct? So it is going to be u divided by g minus a. So now you can see that time for descent is actually less than time for ascent, right? Sorry, time for ascent is less than time for, sorry. This value is less and this value is greater than, right? The denominator is smaller over here. So this value is going to be more. So we are going to write something like this. So this is your final answer. Hopefully you have got it, right? So done, everything's clear. So we have done motion under gravity with air resistance. Now again let's do some problems under motion under gravity. You solve it with yours on yourself, then I'm going to also help you. A ball is thrown upwards with a speed v from the top of a tower and it reaches the ground with speed 3v. What is the height of the tower? All right. So let's quickly solve it. So we have got a tower and a ball is thrown upwards with a speed v, and when it reaches back with speed 3v. This is the thing, right? I know one thing, that if height of the tower is h, when it will fall back to the same height, its speed must be same. That means for this displacement, the change in speed is from v to 3v. Is that correct? So let's use the third equation. Final speed, square of final speed equals to initial speed plus 2a into s, right? So this would be 8v square minus 2gh. So h would be 4v square by g. That's it. This is your answer. 4v square by g. C. Can you get it? How quickly we can do it? Just by this thing, that if it is moving and it was at same level, its speed will remain same. So it was thrown with v. When it comes back, this will be v. Here it is 3v. The change is actually of 2v, right? Displacement is h. Just use the third equation. Let's move to the next question. A stone is dropped from the 25th story of a multi-story building and it reaches the ground in 5 seconds. In the first, this is actually in the first second, it passes through how many stories of the building? All right. So it's also not that difficult. Let's suppose that we have got like, this is a 25 stories. So let's say that each story is of n meters, right? Each story is of n meters. So the total height is going to be, of 25n, right? A stone is dropped from 25-story building and it reaches the ground in 5 seconds. So if it reaches the ground in 5 seconds, you have got like, you can use this again second equation, 25n equals to minus half, and you can use g as 10 t square, right? So 5 is that correct, right? Hopefully everything is clear. And over here I am going to get my ts. Yes, absolutely everything is clear, I think, till here. A stone is dropped from 25th story and it reaches the ground in 5 seconds. 5t square. All right, sorry. So I've got also t. So I've got also 5 square. So I can cancel out this 5 as well, and n is coming out to be 5. So that is 1 stories of 5 meters, right? So 1 stories of 5 meters. So in the first second, if they want us to find out, in the first second, it would be S half A into T square, right? So that would be just 1 story. So that would be just equals to 1. That's it. All right, my friends. So this was not that difficult. Moving on to the next one. Before moving on to the next one, again, we have got one special note over here. Note says a body is dropped from a height h. We know what we are talking about. Find the ratio of distances fallen in first 1 second, first 2 seconds, first 3 seconds. Let's see. If you are talking about first second, I mean first 1 second, not first, but 1 second, it is going to be u is 0, so it's going to be half g t square. For S2, it would be half g t square. For 3, it would be half g 3 square, right? So this is, if we are going to talk about the ratios are going to be S1 is to S2 is to S3. You're going to get 1 is to, you're going to get 4, and you're going to get 9 over here. Is that correct? Please check. This is absolutely easy, right? And next they are saying find the ratio of distances fallen in first second, second second, and third second. So for the next part, just use the formula of nth second. That is u, which is 0, a by 2 into 2n minus 1. Hopefully it makes sense. So for the first second would remain same, my friends. That would be just g by 2, and that is nothing but 2 minus 1, and that's what I'm saying, that would be just g by 2. And for the second, that will be g by 2, and that would be 3. And for the third, g by 2, and that would be 5. So the ratio is going to be, that means first is to second is to third, that would be 1 is to 3 is to 5. Hopefully you have got it, right? Easy things, but you need to remember all of these things, right? Okay, now let's move to the next one. So moving on. Now we have got another note, and this note says a particle at rest is dropped vertically from a height, okay, from a height, let's suppose it is h. The time taken by it to fall through the successive distance of 1 meter each will then be in the ratio of difference in the square roots of the integers. All right, so this is an interesting thing. We can derive it. Let's suppose that we have got a tower again of height h, and let's mark 1 meter of equal lengths. So let's say this is 1 meter. Something like this. 3 will actually do it, right? So, and we are going to say that this is 1 meter, this is 2 meter, this is 3 meter, and so on. So the time taken to fall this 1 meter is, let's suppose it is t1. This is, let's say it is small t, right? Small t or t1, whatever you want to call. This time is, let's say it is t2. This time is, let's say it is t3. All right. Now for t1, it is quite easy. For 1 meter, if they are talking about 1 meter, then you're going to just use, and they are talking about the time taken, right? So you're going to just use S equals to or H equals to half G T square. This is the general formula that we are going to use. So from here we are going to get our time as 2H by G. We are going to use this formula again and again. So for 1 meter, that is for T1, we are going to write it is actually 2 by G. For T2, now this is important. For T2, what either you can use the nth formula and find out what this velocity is, or what you can do is, let's suppose time taken by the particle to reach from here till here is actually, let's say, capital T2, right? So small t2 will be capital T2 minus T1. Think about it. This time will be the time taken by the particle to reach from here till here minus this time. So T2 is definitely root 2, and H is, friends, H is actually 2 meters divided by G minus this is 2 by G. So if I'll take out this thing as common, this will be root 2 by G times root 2 minus 1, and I can write 1 as root 1. This is what they were talking about. Similarly, T3 will be found out by this time. I'll write it as capital T3 minus capital T2. So that will be capital T3 would be 2 by G times 3 minus 2 by G times 2. So that would be root. Is that correct? Everything's clear? Hopefully everything is clear. So that would be root 2 by G root 3 minus root 2. Now you can take the ratios. So that will be 1 is to root 2 minus 1 is to root 3 minus root 2. That is going to be the ratio that we were looking for, right? With this, now let's start next topic, that is graphs, which is now one of the most important topic of this chapter, because again, if you are going to have a good command over graphs from this chapter only, then I mean you're going to come across graphs almost in every chapter in physics, right? Somewhere or the other. So let's look at this. Even in basic mathematics and calculus, we actually talked about some standard graphs. And before starting the graphs of physics, I want you to actually learn graphs in a mathematical way. Obviously, they are part of mathematics, but I want you to learn the mathematics of graphs, right? Before starting the kinematics. So now the thing is, we know that usually we put time on x-axis, we put any other quantity on y-axis, but for now let's put x over here and let's put y over here. It could be any other physical quantity, right? Any physical quantity. If I'm going to talk about a straight line graph, what does it really means? And even in a straight line graph, let's say I'm talking about a straight line graph, something like this, which is exactly at 45 degree. What does it mean? It means that this line is actually y equals to x. Is that correct? This line is y equals to x. Any line. See, the basic concept is that any straight line can be written as y equals to mx plus c, and if it is passing through origin, it can be written as y equals to mx. And m is actually a constant, which basically means that any straight line can be written as y directly proportional to x. This is very important, and because it is important, I'm going to rewrite it over here. So if you are going to come across straight line graphs, then what that would mean, let's start from there. It would mean that y is actually directly proportional to x. in physics we are going to say that as the quantity on x axis is increasing, the quantity on y axis is also increasing, right? So then we are going to come across a straight line graph, and if proportionality constant is greater than 1, then we are going to say that okay, in that case the graph is going to be somewhere over here, and in this case this thing over here is such that the slope is actually greater than 1. For this the slope was 1, and for this one slope will be less than 1. But anyway, they all are straight line, and in all cases y is directly proportional to x, right? So whenever something comes like this, let's suppose now please remember that we are going to use these concepts in kinematics. So this is very important. As x is increasing, if y is also increasing directly, if it is directly proportional to x, then we are going to have a straight line graph, right? The only difference can be that they can have different slopes, right? So we are going to talk about straight line graphs. The equation of straight line graphs is given as y equals to mx plus c, where m is the slope and you know what slope means? Slope basically means dy by dx. All right. So all of these three lines have positive slope. The only difference is this one has less than 1, but obviously greater than 1, right? If you have got a line something like this, obviously you know what negative slope means. We are going to come across that as well. Next is, let's take an example of straight line graph with negative slope. So for this, we are going to say something like, we are going to draw a graph something like this. Is that correct? Right? Now, whatever the quantities, I don't have to worry about that, but this angle is greater than 90 degree. It is intercepting at some value c, right? So definitely it is a negative, it has got a negative slope, right? When we are going to talk about curves, then what will happen? When we are going to talk about curves, then we can't say that y is directly proportional to x, right? That was the case for straight line curves. Then we are going to talk about something like this. Curves can be, so over here again we have got x, we have got y. So the curves can be something like this, right? This is not directly proportional. Y is increasing at a greater rate as compared to x, right? X is increasing with a smaller rate, y is increasing with a greater rate. So this is what we are going to call as curves. Right? So now the thing is, the another major difference here was that whenever we are going to talk about the straight line, the m will be always constant, slope will be constant for a given straight line. Slope is going to be constant, but over here you must be able to read slope here. Slope will actually change, and if you want to find out slope at any point, what you need to do is you just have to do one thing. Just let's first suppose you want to find out the slope at this particular point. So draw a line something like this, a tangent, and then after drawing the tangent, draw a line parallel to x-axis and find out whether this angle is actually an acute or obtuse. Obviously it is an acute angle. Okay, it is theta. Let's suppose it is theta 1. So the slope at this point will be tan theta 1. Now let's choose another point. Again, draw a line parallel to x-axis and a tangent over here. Again, draw angle. Now you can obviously see this angle theta 2 is greater than theta 1. So I'm going to say that M2 will be written as tan theta 2. Right? Also, M2 is greater than M1. So we are saying that over here the slope is increasing. So slope is actually, M is actually equals to dy by dx. Change in y over change in x. But over here itself, M is also changing. So dm over dx is also positive. So this is very important in this particular graph. Right? So what I'm going to say, whichever physical quantity is on y, it is increasing at a greater rate than at x. Right? Got it? Now let's come back to, we have got a decent amount of information over here. Now let's come back to displacement time graph. And when we are going to talk about displacement time graph, we have basically discussed everything over here. Displacement time graph, if you are going to find out the slope of displacement time graph, slope of xt curve will actually give you the velocity. So there are two things basically, one is slope and the another thing is area. So area of xt curve does not mean anything, right? So slope of xt curve basically means dx by dt. So it is very important how we are going to talk about it. Let's suppose we have got a graph something like this and we want to comment on it. Comment everything about the body. So we are going to say that this body is at, first of all, the body is at x equals to x naught. That means it is not at origin, origin is over here, and because its position is not changing, and at rest. That's it. And okay, so sometimes what happens that it looks pretty easy and we move to another question and then we really can't apply the same concept over there because we actually rushed. Please look over here. This is a straight line, but this straight line is parallel to x-axis. That means it has got slope 0. It has 0 slope. Is that correct? And what does slope mean? Slope means velocity. So it means that velocity is 0. So if velocity is 0, it means that it is at rest. I know it is very easy, but still, let's cover all the basic concepts, right? Moving on. We have got two curves. Let's go one by one and see. Straight line, some angle, slope. Straight line basically means slope is constant. Body is starting from origin and slope is constant. What does slope of xt curve means? Velocity. Good. It means that velocity is constant. So if velocity is constant, it means that it is a uniform motion. So body is performing a uniform motion. Is that correct? Body is performing a uniform motion starting from rest, right? Plus, I'm going to also say that it starts from rest. Starts from origin, sorry. Starts from origin. Starts from origin. Not from rest, starts from origin. That would be wrong to say that it starts from rest. If we say that it starts from rest, it means that it will have certain acceleration, right? So, it is moving with some constant velocity. It starts from origin. This is another information. What do you think about it? Comment. Do you get it? Now, whatever over here is, it means that slope is increasing. Slope means velocity. That means velocity is increasing. That means it starts from rest and it is a non-uniform motion. By the way, non-uniform motion plus acceleration is actually positive because velocity is increasing. And how we know that? We know that because slope is increasing. It is positive and increasing. So what does positive and increasing basically means? Magnitude is increasing, that is for sure, but it means that it is moving in one direction towards the origin, in one direction from the origin, right? Let's move. What about this? What is the difference between this graph and this graph? This started from origin. This graph does not starts from origin. Everything is same. It starts from a particular point x naught. Slope is increasing, that means velocity is increasing. Comment this everything about this in the comment section, right? What about this thing? It starts from rest, right? Sorry, it starts from x naught and it moves towards origin. It moves towards origin with constant velocity. With constant velocity. How do I know constant velocity? I don't have to worry about the slope, whether it is positive or negative. I just have to worry about if it is a straight line, that means its slope is constant. That means its velocity is not changing. Is that correct? And how do I know that it is moving towards origin? Because at this particular point, let's say at time t naught, it crossed origin, then it started to move in the same direction from origin, right? So it moves towards the origin with constant velocity. It crosses origin at t naught and it moves and it continues to move in the same direction with the same constant velocity, right? I know that I'm not writing each and everything, but I'm saying it. Please try to understand. All right, hopefully you have got it. Moving on. So I think the next one is this thing only. What about this one? Think about it. Take your time, think about it. Again, what do you think? What is happening over here? So at this particular point it comes to rest, that is for sure, right? At this particular point it comes to rest. If you are going to talk about at x naught, the slope is actually it is 0, and at any point if you want to find out the slope, you're going to make the angle something like this, then again you are going to make the angle something like this, then again you are going to make the angle something like this. So what are you observing over here? You are observing that that angle is actually changing, right? So we are going to say that at this particular point, at t naught, again it comes back to origin, so it moves towards origin. It moves towards the origin, and because it stops at origin, that means it was moving with the decreasing speed. Answer this one in the comment section. This is the first homework question that I am giving you. Not that difficult. You can do it. First, it is decreasing. How do I know it is decreasing? Because at this particular point, slope becomes 0. Right? So speed is decreasing, then speed is increasing. So comment this in the comment section. I've got some more homework for you. Comment these two also in the comment section. Moves away from the origin. Okay. Then it comes to rest. Then it starts moving in the then it starts moving in the opposite direction and comes back to the origin and passes the origin at t2. These two also, write down the answers in the comment section. So I'm going to mark it down so that you can we can assess your answers. So this is my homework question 1. This is my homework question 2. And this is 3. All right. So after this, we are going to talk about velocity time graph also. So similarly, for this velocity time graph, easy, very easy. Velocity is 0. That means the body is at rest, not moving. Constant velocity, straight line. That means uniform motion. Velocity is changing. Why? Because now the slope of, always remember, slope of VT curve will give acceleration. So in this case, slope is constant, and that to a positive constant, which means that we have got a constant acceleration, which means that this is a case for non-uniform motion or uniformly accelerated motion, non-uniform motion. Please let me know in the chat box if you have any problem with the words, although I am using them very carefully, and you must also listen them very carefully. It is a non-uniform motion because velocity is changing, and it is a uniformly accelerated motion because acceleration is constant. Over here, no difference. Initial velocity was 0 over here. In this case, we have got certain initial velocity, that is V0. Other than, we have got same case. Non-uniform motion, acceleration is constant, and velocity is, which means the velocity is increasing at a constant rate, right? So my friends, we have almost completed this chapter. We have got a couple of things left. Slope is negative, my friends. Slope is negative. If you can please see, this angle is greater than 90 degree. So that means slope is negative, which means that retardation, and that's why it is also a non-uniform motion. Body's velocity is decreasing, magnitude is decreasing. After t0 time, what we can say that its velocity becomes 0, then it moves in the opposite direction. Do you get it? What I say, that this is the perfect example for turnaround quotient, right? This is the graph for basically turnaround quotient. What about this one? Velocity is increasing and acceleration is also actually increasing because the slope is increasing. Over here, the slope is actually increasing, and slope is nothing but acceleration. So this means that acceleration is increasing. So this is also non-uniform motion and non-uniformly accelerated motion. Are you getting it? So wherever you put this prefix uniform, it means that whatever the suffix is, that is constant. So if you put uniform acceleration, acceleration is constant. If you put uniform motion, it means uniform is constant, right? Or velocity is constant. Right now, neither the velocity is constant nor the acceleration is constant. So this is non-uniform motion and non-uniformly accelerated motion, right? And the initial velocity is 0. Is that correct? Hopefully everything is clear till here, right? Again, this is question number 4 that I am going to give you in homework. Tell me about this. Tell me quick in the comment section. Again, for the acceleration time graph, acceleration is 0, that means uniform motion. This is actually a uniform motion. All right. For this, the acceleration is constant. Slope is 0, which means uniformly accelerated motion or non-uniform motion. For this one, acceleration is negative, right? And constant. Acceleration is changing, and we are going to say this is a non-uniformly accelerated motion. All right. So with this, friends, I think we have done almost everything. Going to give you these two in homework as well. This is 5 and 6. Hopefully you can do it, right? And with this, we are going to complete this chapter now. And if you have any more doubts, any more concepts which are remaining, please write down in the comment section. I'm going to come up with, I think we are going to talk about, in next week, we are going to talk about motion in a plane. So relative motions, one part will be dealt in motion in a plane only, right? After that, we are going to talk about, in motion of a plane, we are going to basically revise all the equations of kinematics, right? We are going to talk about, the motion in a plane is nothing but, we are going to study, we are going to solve questions of kinematics twice in a one question, right? So it's not like that we have completed kinematics. In another class, we are going to again talk about kinematics. So I'll suggest, please go through this chapter once again with me. Solve these questions on your by yourself. If you have any doubt, please look over here. and then when we are going to talk about motion in two plane, you will be quite good, right? So with this, I'll take your leave. Thank you so much. I'll meet you in the next week, next class. Bye bye.